Alright, this is video 3. We'll cover question number 3 on the 2012 test. I'm assuming you're familiar with the question. You shouldn't be looking at these unless you have already done the problem yourself. So f is a continuous function shown in the picture. It's defined from -4 to 3. It says let the function given by g of x equal the antiderivative from 1 to x of f of t. So essentially what that tells us is that the derivative of g is f, because the antiderivative of f is g. So as long as we keep that relationship in our head, anytime we're talking about g, they're talking about the accumulation of the area under f, and anytime they're talking about the derivative of g, they're just talking about the values of f. So we get to part A. Don't really want to use red ink, so let's go purplish, bluish. G of 2. So G of 2 is simply going to be, if you do the algebra of it, you go back to the equation, G of 2 says plug in 2 for x, which simply means we're going to integrate from 1 to 2 under f of t. And I evaluate from 1 to 2, and that just gives us, unless I'm crazy, this tiny little triangle right here, which I suddenly have found an annoyance with this question, and then I need to kind of really think about the slope of this line, which I haven't done yet. So let's do that. The slope of this line is going to be a change of -1 over a change of 2. So I'm going to go down 1 and over 2. So that means I've gone over 1 and down a half. So this height here is -1/2. So the area of my triangle is going to be 1/2 base of 1 times the height, or -1/2. So I guess we get -1/4. G of -2 now simply says start at 1 and go to -2. Alright, so what we need to notice by this is we are actually moving backwards. So that means any accumulated area that we get is actually going to be the opposite of what we'd normally think in terms of positives and negatives. So the area of the semicircle here is going to actually be negative or positive, and the area of this triangle, because we got to get all the way back to -2, the area of the triangle is going to be negative. So the radius of my circle, so 1/2 pi r squared plus then area of a triangle, 1/2 base times height. So I get 1/2 pi, radius is 1 squared. That's going to be a positive, so really I guess I should think in terms of when I add them together it's going to be negative, or I could just write subtract. 1/2 base is 1, height is 3. So I get an answer of, it looks like 1/2 pi minus 3/2. I don't really like that answer. It doesn't fill me with confidence, but I don't see that anything wrong. Okay, let's see if we can squeeze B on the side here. Let's change pen color. So let's do B right over here. For each G prime of -3 and G double prime, find the value. Okay, so the derivative of G is this picture F. So the derivative of G at -3, 1, 2, 3, is simply the value of the function right here. So once again, I have an annoyance of not knowing the slope. So what are we going to do here? We're going to go over 2. So that's on the bottom. We're going to go up 2. So it looks like my slope is 1. So that means this value is going to go over 1 up 1, so we're at a height of 2. So I know this is the point -3, 2, and so the derivative of the function g, not this function, the derivative of g, well, I guess I might have just said something silly. The derivative of g is this function. I just want to make it clear that this isn't g itself. So really they're asking simply for us to do this. G of prime of -3 is really just f of -3, which we just found is 2. And then the second derivative of g at -3 is simply going to equal the first derivative of f at -3, which is the slope, which we already found is 1. Part C, let's see if I can keep squeezing it in over here. Find the x-coordinate of each point at which the graph of g has a horizontal tangent line. Then is it a max or a min, etc. Okay, so if you want to find where g has a horizontal tangent line, you look at its derivative equaling 0. Here's the derivative. Here's where it equals 0. I think we simply have the answer of x equals -1, x equals +1. All right. Determine whether it's a min or a max or neither of these. So the first one at -1, the slopes, so the function f is going from positive to negative. So that means we have a maximum at x equals -1 because g prime of x equals f of x changes from positive to negative. Or you could use the word slope, and talk about it that way. X equals 1 is neither a max or a min because the slopes of g don't change sign. So I kind of took it both ways. So this time I talked about slopes. This time I just talked about the values of f. Either way, that's kind of the same argument. All right. I'm sure their answers are a little more technical, but that should do the job. Part D, between -4 and 3, so the entire function here, find everywhere that g has a point of inflection. Explain your reasoning. So, very simple. The point of inflection is going to occur where the second derivative is either 0 or undefined, but more importantly, when the second derivative changes from positive to negative or negative to positive, much like we just talked about with the first derivative. So now we're talking about the slopes of f. So right here at -2, my slopes were positive and then they were negative. So part D, I know at least I have x equals -2. Here my slope is undefined because I have an immediate change, not gradual, but I go from negative slope to negative slope. So that doesn't count. Looks like x equals 0. My slope changes from negative to positive, and then x equals 1, positive to negative. Find all the values, explain your reasoning. Okay, so those are the values, and now for the reason. Let's say at each of these values, the slopes of f change signs. And again, that's probably enough, but let's just say, therefore, the second derivative of g would change from positive to negative, or vice versa. Again, not a great explanation, but Good enough. Alright, so let's pull up the scoring guide, or if I can find it. So 2012 and scoring guidelines. Okay, so here it is. So for part A, they got -1/4. For part B, they got negative 3/2 minus pi over 2, so pi over 2 minus 3/2. Let's see what we got. A little crowded on my screen here. Alright, same thing. -1/4, 1/2 pi minus 3/2. Got 2 points, one for g of 2, one for g of -2. Part B, when g prime equals f of x, or g prime equals f of x, therefore g prime of 3 is f of -3, which is 2. Second derivative would be the slope, which is 1, and those are the values we got. 2 more points. Part C, horizontal tangent line, where g prime equals f of x equals 0. This occurs at -1 and +1. G prime changes sign from positive to negative, therefore it's a relative minimum, or maximum, excuse me. No sign change, therefore it's neither. It occurs to me the first part of C there, they've put some explanation, and I did not do that. So let's see if I should have. Find the x-coordinates of each point at which the graph is horizontal for each. Okay, it doesn't, well, it says justify your answers here. So there's a chance they may not like the fact that I found -1 and +1 without explaining how I knew. So that might have cost me a point or two there. So anyway, just good lesson to learn there. When it says justify your answers, you better go back and make sure you've talked about all parts. Part D, inflection point at -2, 0, and 1, because g double prime equals f prime changes sign at these values. So yeah, so we got that one. So I think we got ourselves probably 8 points. We might have missed this point right there. All right, let's see how everybody else did. Question 3, how well? 2.67 is all. Not giving me how many got 0 and how many got 9. But 2.67 is really low for this question, I think. So hopefully you did much better than that. Okay, stopping this video now.